Hi, kids. It's time for some more math. Unit 5. I'm just checking to see if my cam's working. Which way should I move? Seems like I'm not in the middle. Which way should I move? Right or left? Move it a little bit left, maybe? Seems like somebody's bumped my camera a little bit. Oh, look, I'm like in the middle now. Okay, kids. Unit 5 is just about over. It's so exciting. So, here's the test. Is my pen going to work? Because I haven't even tested it yet. Oh, let's just do oh, yeah. Let's just do some random stuff. Oh, we'll draw a box. Look at the box. Oh, the box was fun. Oh, another box. Apparently the pen is not going to work. We'll see. Going to draw. Mr. Key. Ooh, wow, it looks pretty good, actually. Hey, maybe I just needed to warm it up a little bit. So anyway, this document can be found at mrkrausemath.com. Kraus spelled Krause. So Mr. Kraus. Maybe I should write that down there because some of you don't seem to find my website. You should have kid go, I don't know what the website is. www.mrkrausemath, all one word, .com. How much more easy? Well, that's not even English. How much easier could that be? All right, kids, let's get rocking and rolling. By the way, if you haven't hit subscribe button and you're one of my students, I might just fail you because I don't like you. And if you're one of my many followers across New York State because you really love my videos, thank you very much for showing up. I appreciate it. A little time for a commercial for you. If you're out drinking, drink this coffee. It makes your brain work better. Yeah, I'm a little addicted. Anyway, let's get going. So, guys, anytime you see squares, hey, you know you're going to be factoring. So we know we're going to be factoring. We also have a division symbol that needs to get flipped. But I'm going to tell you the first thing my eye went to. And my eye went to this. Raise your hand if you know why. Bubby? I don't even have a Bubby, but I'm calling on Bubby. Yes, of course, that's the -1 rule. So there's a very good chance we're going to be using the -1 rule. Division turns to multiplication. Let me write myself a little reminder to flip this one. In fact, I'm going to do this one first so I don't forget to flip it. And because x minus 2 is really easy. I like the easy ones. In the numerator, I can take out an x. Guys, if you're going to take out a GCF, that means you only have one set of parentheses. One. I could use the other finger, which is right next to it, to tell you about one, but I might get in trouble. Somebody would freeze frame it, throw it up on YouTube, and be like, Mr. Kraus is a potty mouth. Which I am, but that's okay. You'll get over it. So, because this is backwards, you guys got to get really comfortable. Because this is backwards, instead of it being x plus 6 and x minus 6, because the 36 comes first, it's 6 plus x and 6 minus x. Okay, the denominator, not so bad. You know why it's... Well, the denominator is really bad. And the reason the denominator is really bad is because it is not correct. So I have to get the Word document up to see what it actually is. It's missing. I don't know what happened with Office, so it should be a 12. OneNote, every once in a while, it just somehow leaves out numbers. Just kind of trying to make my life interesting, because there's no way to multiply to 1 that adds up to 8. But I can multiply to 12 that adds up to 8. And that would be 6 and 2, and both of them will be pluses. So, now I take out my big black pen to knock stuff off. Now this one and this one, they just cancel. Addition does not the -1 rule. It has nothing to do with the -1 rule. When I do the -1 rule, I like to drink Brugger's coffee. I drink Brugger's coffee all the time. It makes me happy. It makes me do math better. It doesn't earn me any money. like it probably should, so I can get a new computer, because this is slow and obnoxious. But it certainly peps me up to finish the video. Awesome. Ooh, wait, hold on. This is an x plus 2. That does not cancel with this x minus 2. Let me just make sure that was supposed to be an x minus 2. Okay, good. Wait. Yeah. All right. But where are we going? What happened? What happened to my pen? This x minus 6 actually cancels with this x minus 6, but it makes negative 1. Not minus 1, negative 1. We're going to multiply by it. So my final answer is negative x minus 2 all over x plus 2. Catching! All right, kids. So I'm just starting you right out here. Well, maybe we'll just keep going. All right, so this one we're just going to start factoring. I don't have division. I don't even see the negative 1 rule. I do see something odd. A minus B. Something that's bothering me. These 4s are sort of bothering me. Are they bothering you guys? Stop whining! You're irritating me. Whining babies. They're just 4s. It's 2 times 2. Freaking easy, man. What's wrong with you kids? Taking me off. GCF. I can take out an A. Notice I'm sticking with the easy ones first. I'll get to that really hard one later. I know, it's so difficult, Mr. Krause. A plus B. All right. Whoa, 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 whoa. That one's so difficult. We'll start with the top one. The top one is the difference of perfect squares. It's A squared and A squared plus and minus B squared and B squared. Now, this is also the difference of perfect squares. Let me grab that in a different color. That's A plus B, A minus B, hence the 4th. You're going to be doing a little bit more work. It's not that difficult. You guys can handle it. You guys are awesome. Did I ever tell you I got awesome students this year? Awesome. By the way, just in case you're wondering, I may not be there on Monday. I might be like in the Caribbean or Europe or just flying around the world a few times in my private jet after I win $800 million in the lottery. If I win $800 million in the lottery, I'll still be drinking Dunkin' Donuts or Brugger's coffee. I just won't need your money, which I'm not getting anyway. Okay, now let's tackle this hard one. Let's take a look at this hard one. All right, by the way, I say hard, but, you know, of course I'm being sarcastic and facetious and joking around with you. I don't know which one's the right word. Let's do this in different color, green, because green makes it look easier. So, come on, kids. There's only one way to get A squared. A times A. Guess what? There's only one way to get B squared. B times B. Wait a second. The signs are going to be the same, and they're both going to be negative. Done. That's it. Now pay attention. I mean, you should know that this is going to work. This is negative AB, and this is negative AB, and that makes negative 2AB. Done. All right, let's go. Let's see what we can cross off. A minus B, A minus B, A plus B, A plus B, A minus B, A minus B. That's it. A squared plus B squared. Put it in parentheses so you don't do anything stupid here at the end, all over A, like crossing off one of these A's. That'll get you hand slapped. All right, let's keep going. Oh my God, 3 fractions. I feel like I've died and gone to fraction heaven. You guys thought I was going to curse, get in trouble. I wouldn't do that. All right, they're all easy. This one, GCF. Let's take out a 4. X plus 2. Bam. X plus 1. Simple. This one, alert, alert, it's backwards. Negative 1 rule is coming. A negative 1 rule may be closer than it appears. It's backwards. Probably going to be the negative 1 rule. 3 times x minus 5. I probably should have started this one because it's back upside down, right? And we got to flip it. So x plus 2, x minus 2. And the numerator, oh man, it's got a 2 in front. Let me just make sure it's right before I start messing with it. Yep, that's what I thought. We lost a 0. Thought we were missing a letter. This has a GCF, so we'll take out a 2. X squared minus 4x minus 5. That's really an annoying feature of this silly computer. Oh, maybe it won't happen on my new computer. So we have a 2. And then you can't throw it away, kids. Stop throwing away GCFs. They don't get thrown away. X and X. They got to multiply to -5, add up to -4. So that would be -5 and plus 1. All right. Lots of stuff's going. Let's bring out the black pen. +1, +1, +2, +2, -5. -5. Now, these two cancel, but they make -1. I think that's it. In the numerator, I have 4 times -1 times 2. That's -8. The denominator does a 3. Done. Bodied. Whoever thought of that was an idiot. Okay, now we're adding and subtracting. So in order to add and subtract, why is that down a row? That's weird. Things pushed down. Oh my god, this did not print very well. Okay, so anyway, in order to do this, we need a common denominator. But the first thing I'm seeing here is not my pen. Okay, so the first thing I'm seeing here is this is backwards. Backwards. So what I'm going to do is I'm going to turn it around. 2x minus 6. Now, I can't legally do that without introducing a negative. A negative. And as soon as I do this, you'll notice now my denominators are common. So I have a common denominator, which is beautiful. So it's 2x minus 6. And my numerator is 3x minus 9. Remember, keep things in parentheses so you don't do anything stupid. Now, welcome to not 8th grade math, kids. You got to keep looking. Is there more to do? Of course there is. We're in trig. Take out a 3. I'm left with x minus 3. Take out a 2. Guess what I'm left with? You guessed it, x minus 3, and the x minus 3's cancel, and your final answer is 3 over 2, and oh my gosh, math is awesome. Okay, it's not awesome, but it is kind of fun, especially when you get the right answer, because it's like, yes, I get the right answer, and of course if you get the wrong answer, then it's like, crap, I got the wrong answer. All right, so let's put this in parentheses so we don't do anything dumb, and our lowest common denominator would be x plus 3. X plus 3. There we go. That's our common denominator. So here's what we're going to do. Now, if we don't have an equal sign, this is what we do. We make the denominators the same. Now, if I look at these denominators, this one has an x, but it doesn't have an x plus 3. So we're going to multiply the numerator times x plus 3. Well, that's kind of boring. It's just x plus 3. Yes, I know you can cancel the x plus 3s, but that would leave you with 1 over x, so don't do it. I always get that kid who goes, oh my god, the x plus 3s cancel! Duh, we just put it in there. And this one has an x plus 3, but it's missing an x. So what we'll do is we'll add in an x to the numerator. So now that I have the common denominator of x plus 3, I'll add the numerators together. 2x plus 3. Leave it in parentheses. But we're in trig, and we got to look to see if we can keep simplifying. We can't. So we're good. When I'm about to scream at students, I drink Brugger's coffee. Alert! 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 We have a minus. We have a minus. We must distribute that minus. Change this to a plus. Put that minus up there. Whew, that was close. Thought we were going to screw that up. Ooh, my glasses are so dirty. Oh. At any rate, let's do this. This is x plus 1. x minus 1, and over here we just have x plus 1. So yes, students, you are correct. The common denominator is, in fact, x plus 1, x minus 1. X plus 1, 1, x minus 1. So I take out my highlighter and I go, okay, this one has x plus 1, x minus 1. It's not missing anything, so I don't have to change the numerator. Oh, that's awesome. 3x plus 1. But this one only has an x plus 1. It's missing this. So I got to multiply it times x minus 1. Now, remember, we're distributing a negative here. So negative times x is negative x. And negative times negative is positive 1. Well, now that the denominator is the same, that sounded like an alcoholic. The denominator is the same. I got the denominator is the same. When I wake up from a hangover, I like to... I'm just kidding, kids. I don't even drink anymore. Because I can't. Stupid foot. All right, so now that... I'm not going to be able to say it. Now that the denominators are exactly the same, I can just add up the numerators. So I get 2x and then plus 1, and plus 1 is plus 2. But, of course, we're not done. I can take out a 2 out of the numerator. 2x plus 1 all over x plus 1, x minus 1. And the x plus 1s cancel, and I'm left with 2 over x minus 1. And it's so beautiful! I love math, Mr. Krause. It's awesome. And I probably just put that over my big fat head so you couldn't see it. So let me just slide it up so you can see it. Better? All right. Maybe what I'll do, I'll just move that over. Maybe what I ought to do, you know what I ought to do? I ought to do this. I ought to just go, bam. Let's go to like 150%. No, that was useless. Let's go to like 200%. Oh, yeah, it's huge-mongous. My son used to say huge-mongous. I don't know why. He's a little weird. So, let me get rid of this crap over here. Draw, erase. All right, so here's what we're going to do. We're going to do this. We're going to factor each one of these. Now, this is going to, I blew it up, and this one requires like the most amount of space. So let me see if I got enough space here. Okay. So this one is going to be a minus 3, a minus 2. This one is going to be, I think we're missing something here. Alert, alert, we're missing something. 12, of course we are. The last one okay? Last one okay. So, a minus 3, a minus 4. This one is a minus 2, a minus 4. So if I look in the denominators, I see an a minus 3. That's new. This one has an a minus 3. I see an a minus 2. This one has an a minus 2. And an a minus 4. Those are the only three things that I see in the denominators. Nothing else. I don't want to highlight anything else. I've already highlighted an a minus 3. And I've already highlighted an a minus 2. And I've already highlighted an a minus 4. So I don't have to highlight those again. So those are my common denominator. Come on. A minus 3, a minus 2, a minus 4. Put everything that you see that we've highlighted in your common denominator. Okay, so this one has a minus 2 and a minus 3, but it doesn't have a minus... I should put these in parentheses. It doesn't have a minus 4, so this one's going to get a minus 4. This one has a minus 3 and minus 4, but not a minus 2. Ooh, difference of perfect squares. Conjugates! And this one is missing a minus 3. So we're going to multiply times a minus 3. Now, because I hate writing that denominator so many times, which is a minus 3, a minus 2, and a minus 4, I'm going to clean this stuff up here. Let me do it in a different color. So this is a squared, that's too big, minus 4a and plus 2a is minus 2a minus 8. This one is a squared minus 4, and this one is just a minus 3. All right, let's combine everything. We got to add, so we get 2a squared, and then I've got minus 2a and plus a, so that's minus a, and then minus 8 minus 4 minus 3 is minus 15. And I really should look to see if I can simplify or factor that. I'm going to run my big test. B squared minus 4ac. B squared minus 4ac before I see if I can factor that. So that's 1 minus 4 times 2 times negative 15. See, 8 times 15. 15 times 8. That's 80 plus 40 is 120. So that's 120, so it's 121. So this is, in fact, factorable. Remember, if the discriminant is a perfect square, let me move this over so it's away from my big fat head. If the discriminant is a perfect square, then it is, in fact, factorable. Let's see. It's got to be 2a and a. There it is, 5 and 3. This one's going to be minus, and this one's going to be plus, because that gives me negative 6, and that gives me positive 5, which gives me 1. So, lo and behold, I'm not even done yet. The a minus 3's cancel. So my final answer is 2a plus 5 all over a minus 2, a minus 4. God, that was fun. Oh my God, Mr. Krause, I got it! Yay! And if you didn't get it, I'm sorry. Okay, complex fractions. Oh my God. When you heard the word complex fractions, did you get a little funny? Did you get a little excited? I did. Hard fractions. It sort of brings a tear to my eye when I get to do hard fractions rather than just regular fractions. Okay, kids, this is not that bad. Remember in class, what we learned was we're looking for the lowest common denominator. You look at all three. Let me highlight them. X, Y, Y. What is the lowest common denominator? We've done it now 3 days in a row. You need to find the lowest common denominator. In this case, it is X, Y. So we're going to put an XY next to every one of these. XY, XY, XY. All right, so in this one, the Y cancels, and I distribute, and I'm going to write it as X times X minus Y. In the denominator here, the Y's cancel. I'm left with X minus. Here the X's cancel. Y. Those cancel. My answer is X. Seriously? That problem's that easy? It looks so complicated. All right. So I don't like the way this one's written. So I'm going to rewrite it. I didn't do that last one because the last one they were all written as fractions. So I'm going to write it as n over 1 minus 1 over n all over 1 minus n squared over n. My lowest common denominator is just n. Because if I look at all three denominators, n, and 1, lowest common denominator is just n. So I'm going to put an n next to everything. N, and n. So here nothing cancels, so I'm left with n squared. Here the n's cancel, I'm left with n squared minus 1. Put that in parentheses. Here the n's cancel, and so I'm left with 1 minus n squared. Well, I don't need to factor it. This is the classic -1 rule. These things will cancel each other out because they're exactly the same but backwards and give me... Seriously? That's it? Yes! Oh my God! Complex fractions are fun! Complex fractions are fun! Alright, let's look at these denominators. I got a 2, I got a D, I got a D, and I got a 2D. 2D or not 2D? That's the question. My lowest common denominator, of course, is just 2D. So I need to put a 2D next to everything. Let me write this big so you can see it. 1/2 minus 4 over D all over 1 over D plus 3 over 2D. When am I ever going to use this stuff in my life, Mr. Krause? On the test. To pass my class. Now shut up. Putting the 2D here. I say shut up in the nicest way. Alert! Oh, we got a minus. We almost forgot to take care of it. Oh, my God. I'm so glad I caught that. It could have been bad. 2D here. Actually, in this case, it wouldn't have made any difference, but that's okay. All right, let's start lopping crap off. This 2 cancels with this 2. It leaves me D. This D, ooh, I forgot to put a D here. That would have been bad. This D cancels with this D. It leaves me minus 8. All over. D cancels with D. It leaves me D. Plus 2D cancels with 2D. It leaves me 3. Put these in parentheses so you don't do anything monumentally stupid and say, that's your answer, kids. And there she wrote. Is that it? Those are simple. All right. Now we're going to get to some of the harder stuff. Chillin'. I say harder sort of in a comical way because it's all so easy. Oh, Mr. Krause, you're right. It's so easy. Wow, this is like a joke. I can do it like in my sleep. When I talk stupid, I drink this stuff. I'm going to finish this cup of coffee before this practice test is over. Alert! Oh my gosh. That would have been awful, children. If I would have missed this minus would have been awful. It needs to get distributed here and to here. I guarantee you cannot get this right if you miss this. This is a plus, minus, plus. Put in parentheses. Oh, thank you. I didn't miss it. All right, and this is x plus 1. So my lowest common denominator is x plus 1. That's my lowest common denominator. So, now, unlike in the past problems, like where I tried to make them all the same denominators, now I'm trying to get rid of the denominators because I don't want them around when I go to solve this. So I'll put this x plus 1 next to every one of these. X plus 1, x plus 1. All right, so now I'm going to start crossing stuff off. This x plus 1 cancels with this x plus 1. It leaves me 3x squared. 3x squared. This x cancels with this x, and it leaves me a problem. So I'm just going to write it. Negative x plus 8 times x plus 1. That's a lot of work, so I'm just going to leave that there. And this, the whole thing just cancels. So it just leaves me 5x squared plus 2. Let me make sure it's just a plus 2. It is. So I have 3x squared plus, well, I don't know why I put that there. Let me just double distribute this out real quick right here. Negative x squared. Let's see, this is minus x and plus 8x. So that's plus 7x plus 8. So minus x squared plus 7x plus 8 equals 5x squared plus 2. Everything has to come to this side because this is your biggest squared and it's positive. So let's see, this is really 2x squared. So I'm going to subtract 2x squared. And then this is minus 7x. And then when I bring that minus 8 over, I get minus 6. Oh, man, this looks awful, Mr. Krause. 2x and x. And I know I can't put a 2 with this, so probably a 3 is going to be here. Probably a 2 is going to be here. Minus 6. 2. That's not going to give me 7. Oh, what am I, a freaking moron? I just said I can't put a 2 here, and I put a 2 there. So I'll put a 3 here and a 2 here. Well, that's going to give me 7, but it doesn't give me 7 the right way. Okay, kids, still resuming. Okay, let's go. I found my mistake, and it's a little embarrassing because I'm like, man, what's going on? This is not going to work out, and I could not look at my thing. This should be a 3. I don't know what I was doing. So this should be a 3x. And so therefore, let me erase all this. If that should be a 3, so that was my brain fart right there. This should have been a 3. So 3x squared. So now if I do my factoring, obviously someone was sitting there going, oh my God, is he ever going to find it? It's 3x and x. I can't put the 3 here. The 3 has to be here. And the 2 would go here. Minus 3 and plus 2 gives me negative 7. So my two answers are 3 and negative 2/3. Now, I also have to go back and look. Are those any numbers that are restrictions on the domain? And the two domain restrictions are -1 and 0. So both of those work. Wow, I'm glad I found that mistake because that was making me mad. I don't know. Oh, yeah, we're not over there anymore. We're still here. So 12. Let's do some work. So let's do a little bit of factoring. Dish, ding, ding. Oh, alert, alert. We got a plus. This goes to a minus. This goes to a plus. Whoo. Oh, here comes my dog. You ready for a cameo, dog? X minus 4, x plus 2. So my common denominator is x plus 4, or excuse me, x minus 4, x plus 2. So let me get rid of all this stuff, get it out of my way. So what I'm going to do is I'm going to put an x plus 2, x minus 4 next to each one of these things. Briscoe, Briscoe, lay down. Good boy. What a good doggy. I got a good doggy. Now in about 2 minutes he's going to get bored and get up and walk around and make me mad, jingling around. X plus 2, x minus 4. Okay, so whew, that was a lot of work. Took me like 30 seconds, Mr. Krause. I don't like that. So, so in this one, get my black pen out. The x plus 2's will cancel. And it leaves me all of this. So minus 3x plus 12. Notice I distributed that. This one, the x minus 4's cancel. See, he's already up and around. So I get plus negative 2x plus 5 times x plus 2 equals. Now the good news is this all cancels, so I don't have to do anything crazy with that, but it's just negative 20x plus 2. All right, sorry, I had to get rid of the pooch. Good, we're still recording. All right. So now we can clean stuff up. Let's see what we got here. Let me get to a different pen. So this is negative 2x squared. Minus 4x and plus 5x is plus x plus 10. All right, so we've got, let's see if we can clean all this up. Negative 2x squared minus, come on, pen, 2x plus 22 equals negative 20x plus 2. And just to make sure I have the right numbers, just come on, get off my screen. Looks good. Okay. So, since this is negative, everything's got to go to the right side. So 0 is equal to 2x squared. I'm going to add 2x here, so I get minus 18x. And I'm going to subtract 22 from this. And I get negative 20. Good news is I have a GCF. 2x x squared minus 9x minus 10. And the really good news is this one's got some simple factoring. X minus 10, x plus 1. So my two answers are -1 and 10. Yay! Done! Alright, we're almost finished, kids. Oh, we're going to end with an easy one, looks like. And this is x plus 5, x minus 5. So we're going to put an x plus 5, x minus 5 next to each one of these. X plus 5, x minus 5, x plus 5, x minus 5. So put that next to each one. The x minus plus 5s cancel, and I'm left with all of this. So distribute it. X squared plus minus 5x. These x minus 5s cancel and distribute this. Plus 9x plus 45 equals 50. So my x squared is positive. We'll leave that there. Now x squared plus 4x. When I bring this over, I get minus 5 equals 0. I subtracted 50. Holy mackerel, this is a simple problem. X plus 5, x minus 1 equals 0. My two answers are x equals -5 and x equals 1. But just like I didn't do on the last problem, you got to take a look back at the original problem. And the original problem, I have an x plus 5. If I put a -5 into that, it's undefined. So I cannot include this as a solution. So my only solution is 1. All right, moving down. Solve and express in the roots in a plus bi form. This says you're not factoring this, kids. Not going to happen. So what I have here is 2x over 1 plus 3 over x equals -2 over 1. My common denominator is x, so I'm going to put an x next to each one of these. This is 1, they cancel. So I end up with 2x squared plus 3 equals -2x. Well, it's just a quadratic. I got to set it equal to 0. So I get 2x squared plus 2x plus 3 equals 0. Now I could try completing the square, but I'd have to get rid of this 2 first. And that would give me 3/2 here. So that's not very nice. So I'm going to do the quadratic formula. A equals 2. B equals 2. C equals 3. And D is equal to 4 minus 4 times 2 times 3. Let's see. That's 8, 24. So this is equal to -20. Now I'm going to bust out the quadratic formula. X equals -b, so -2 over 2 times 2, plus or minus the square root of -20 all over 2 times 2. Now the square root of -20 is really equal to, well, the negative is an I, so 4 times 5, and this is just 2. So this is really just 2i square roots of 5. So now I simplify it and I'm finished. This 2 cancels with this 2. It leaves me -1/2 plus or minus this 2 cancels with this 2. I square roots of 5 over 2. There she is, kids. That's all she wrote. Let's move on. Graphing rational functions. Oh my gosh, we haven't talked about asymptotes. Which points are restricted from the domain? So I'm, excuse me, I'm only asking for domain. I'm only asking for domain. So I'm trying to figure out what values can x not be. So as I come along, I see x can be, and it's going forever and ever this way. It's going, but wait a second. What happens here? It's an asymptote. And another asymptote. So what value can x not be? X cannot equal 3. So x cannot equal 3. 16. Find the vertical and horizontal asymptotes. So the vertical asymptotes, if you remember, are the ones, remember this is a vertical line up here, are the ones where x makes it undefined. So my vertical asymptote is x equals negative 3. So I know that x can't equal negative 3. All right, kids. So what I did was I just wanted to boot up my calculator. So what I did was I think the easiest way sometimes to look at these is graphically. So if you look at, oops, not that. Don't want to look at that. If you look at it graphically, I decided to graph it for you here. You'll see that here we have the asymptote at x equals negative 3. I can't draw in here. So 1, 2, 3. So right here at x equals negative 3. And sometimes if you look at it like this, you'll see, okay. Well, I also see that there's a vertical or horizontal asymptote right here at x equals negative 1. X equals negative 1. And the reason for this is this could never equal 0. I can never make this equal to 0. So if that can't equal 0 and I subtract 1 from whatever that is, it really could never equal negative 1. So my horizontal asymptote is y equals negative 1. And if you remember way back when, the rules are if the degree of the denominator is bigger than the degree of the numerator, there's a horizontal asymptote at 0, but we subtracted 1. This one is we have a vertical asymptote at x equals negative 2, and since this cannot equal 0, if we add 5, y cannot equal 5. So that one's y equals 5. And again, if I wanted to graph that, escape. Why can I not tab? Tab. Oh, there we go. If I want to graph that, and it's 4 over x plus 2, x plus 2 plus 5, right? And I want to graph that. I see my vertical asymptote is at negative 2. It's hard to see here. No, I can't even expand it. But I also have a horizontal asymptote up here at 5. It's hard to see where it is. Oh, there it is. I can do that now. So there's my at negative 2 and up here at 5. So that one's not too bad. Find the vertical and horizontal asymptotes for this one. So my, oh, sorry. I thought it was missing a letter. Here we go again. Come on, catch up. I don't have to go back and forth between problems. So, clearly the vertical asymptote is what makes the denominator undefined as x equals 1. And this can never equal 0, so y equals 0 is my horizontal asymptote. This one might be better just to graph it. Take a look at it graphically. Let's look. Tab. Let's just go. No. Let's get rid of this. No. Going back in. Control negative. Control division. 3 over x minus 1. Clearly, it's x equals 1 is your vertical asymptote. But what's going on with that negative? Is that anything? Well, x equals 1 is my vertical asymptote, but we can get that in there pretty easy because that's what makes this undefined, right? Vertical asymptote, x equals 1. But look what happened. We got x equals negative 2. Did that change anything? No. We got a horizontal asymptote with x. The only difference is it reflected. So instead of it being down here and up here, that negative just did a reflection. So you notice it had nothing to do, again, with your horizontal and vertical asymptote. Y equals negative 2. Done with that, I hope. Now we're doing inequalities, solving rational equations. Okay, so my critical numbers are 4, negative 7, and 9. So negative 7, 4, and 9. So it gives me 3 areas to check, 4 areas to check. So if I plug in negative 10, this is negative over negative times negative. 3 negatives make negative. If I plug in 0, the numerator is negative. The denominator is positive. Negative. 2 negatives make a positive. If I plug in 5, the numerator is positive. The denominator is positive, negative. That's negative. And if I plug in 10, everything's positive. So I want where it is positive. I want from here to here, positive, and from here out. Now, do I want to include them? Well, there's no equal to, so I don't want to include them. So my answer is negative 7 to 4 union 9 to positive infinity. All right, moving on. Now I got a factor, and I know there's a number missing here. All right, so this is x plus 6, x minus 2. So my numbers, or my critical numbers, are negative 2. My critical numbers, should have written that over here, are negative 2, negative 6, and positive 2. So let me draw my number line. Negative 6, negative 2, positive 2. So it breaks it up into 4 areas. All right, so if I type in a large negative number, the numerator will be negative. The denominator will be negative, negative. 3 negatives makes negative again. If I plug in negative 4, the numerator is still negative, but this is positive and this is negative. So 2 negatives make a positive. If I type in 0, the numerator is positive. The denominator is positive, and 0 minus 2 is negative, so that's negative. And, of course, this will be positive, 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 positive. And, again, I want positive. So it seems like something's missing in this problem. What number are we on? 21. Nope. Okay, so I want between these two. Basically the same problem as last time. That's why I said I thought something was missing. So negative 6 to negative 2 union 2 to infinity. I didn't include them because there was equal to. So x plus 5, x minus 5. So my critical numbers are negative 5, 0, and 5. Negative 5, 0, and 5. So, and 0 comes from what makes this equal to 0. So if I pick negative 10, that's going to give me negative over negative n times negative. So that's 3 negatives, makes a negative. If I plug in negative 2, the numerator is negative. Negative 2 plus 5 is positive, and negative 2 minus 5 is negative. 2 negatives makes a negative. And this will be positive if I plug in 2. Well, will it? Hold on, let's just check this craziness out. Oh yeah, because the numerator will be positive and the denominator will be... Oh, this should have been... What am I doing? I'm losing my flipping mind. Okay, hold on. So let's go back. Two negatives makes a positive. Okay, now if I plug in positive 2, the numerator is positive, this is positive, and this is negative. So that's 1 negative makes a negative, and here everything would be positive. Now what am I looking for? I'm looking for negative. I'm looking for when it's below 0. So I'm looking for this area, and I'm looking for in between. I don't have an equal to, so open circles. So negative infinity to 5. Oops, negative 5. No, including either of them. Not. Union, not including 0 or 5. There it is. Oh, we got a lot of work to do here. This is x plus 2, and this is x minus 9x plus 5. So I have 4 critical numbers. My critical numbers are negative 5 is the smallest, negative 2 is the next smallest, 0, and positive 9. So let me draw that number line in. Negative 5, negative 2, 0, and 9. So I've got 5 areas to test. The first area I'm going to test is way out here. I'm going to select negative 10. Negative 10, when I put negative 10 in here, that's negative. When I put negative 10 in here, that's negative. When I put negative 10 in for x, that's negative. When I put negative 10 in for here, that's negative. 4 negatives is a positive. Now I'm going to put in negative 3 in the numerator. This is negative. And this is positive. Negative 2 plus 5 is negative, or is positive. That's negative. And negative 3 plus 2 is negative. So 3 negatives makes a negative. Now I'm going to plug in negative 1. Negative 1 minus 9 is still negative. Negative 1 plus 5 is positive. Negative 1 is just negative 1. That's just negative. And negative 1 plus 2 is positive. So that's 2 negatives. That makes a positive. Let's try 5. 5 minus 9 is negative. 5 plus 5 is positive. 5 is just positive. And 5 plus 2 is positive. So 1 negative makes a negative. And, of course, this is going to be positive. The only thing I want is where it's positive. Positive, positive, positive. I want the positive areas. Open circles on everything. Open circle going this way. Open circle in between these two. And open circle going that way. So, negative infinity to negative 5. Union. Union. Negative 2 to 0. Union. 9 to infinity. Infinity and beyond. What do we got next? Complex fractions? Oops. Oh, we already did complex fraction. Inverse variation. I probably should have taught this. View. Minus. So I'm going to do inverse variations in probably, in 2 seconds in class. So I will have done this. So inverse variation is the formula xy equals xy. Done. Xy equals xy. That's inverse variation. That's all you got to remember. It's a simple formula. As one goes up, the other one goes down. As one goes up, the other one goes down. So if I tell you you have a rectangle and the length is 12 and the width is 6, length is 12 and the width is 6. X and Y in this case, length and width. 6 times 12 is inversely proportional. Calculate a rectangle whose length is 9. So 9 times Y. That's it. That's all we got to do. This is 72. 9 divided by 9. I get Y equals 8. Done. They just got to multiply to make sure. Varies inversely, they just got to multiply to equal each other. That's all it is. When you calculate the air pressure pumped in albatross, inversely proportional. As soon as you see inversely proportional, it's xy equals xy. Now, xy could be anything. It could be length times width. It could be, whatever 2 things it is. Pressure and volume, whatever. So in this case, it's pressure and volume. So we've got a pressure of 35 when we got a volume of 120. So we're going to take those two things, and we're going to do 35 times 120 is inversely proportional. So when the volume is 140, so we know in this case, we know the 140, but we don't know the pressure. So we'll just put an X here. And I just solved. Divide by 140, divide by 140. I need my calculator for that. 35 times 120 divided by 140 equals 30. So the answer is 30. X equals 30. I should put the pressure equals 30, but we won't do that. And one more varies inversely. Where is it? Vary inversely. XY equals XY. As soon as I see it, I write XY equals XY. All right. So a pulley that has a diameter of 8 inches is belted to a pulley that has a diameter of 12 inches. So we've got 8 inches and 12 inches. The 8-inch diameter is running at this. So 8 times 1548 per minute. If the speed of the pulleys vary inversely to their diameters, how many revolutions per minute does the larger pulley make? So 12 times X. So I take out my calculator. 8 times 1548. 8 times 1548 equals 12,384, and divide it by 12. 1,032. Varies inversely is very simple. I'll cover that in like 30 seconds in class with you guys, okay? Varies inversely. Very simple. I think that's it. That's the end of that test. Yay! Oh my God, it only took like an hour to complete. Nice job. You guys are rocking. Have a great day, kids. Bye. Hit subscribe, hit like, and if the commercials suit your fancy, hit those